Hi, everyone. We're going to go ahead and get started. My name is Tom Shane, and I'm an MIT Sloan student on the research papers team. And I'm here to introduce Sean and John, who will be talking to us about their paper on mixed membership martial arts, data-driven analysis of winning martial arts styles. They'll give about a 20-minute presentation, then we'll have time at the end for Q&A. So with that.
All right, thank you for the introduction. I'm Sean Hackett. Oops, sorry. Mixed martial arts is a sport where athletes from diverse backgrounds come together to compete in full contact matches. Now, the sport of MMA is broadly characterized by this fusion of diverse martial arts styles. But we can also understand individual athletes as using a subset of the possible moves they could utilize, and thereby they're a mixture of a set of prototypical martial arts styles. Now, this intuition led us to develop the Mixed Membership Martial Arts Model, or 3MA. So to kind of talk through what we're going to try and do with the 3MA model, we can consider three fighters. One is a striker, who's won by punches, elbows, and kicks. One's a grappler, who's won by arm bars, chokes, and toe hold. And there's a balance fighter, who's won by a few strikes and a few submissions. Now, what we want to try and do is identify two different pieces of information. We want to say what is the nature of these prototypical martial arts styles by associating individual finishes with a set of kind of prototype labels. So we want to say that punches, elbows, and kicks are strikes, armbar, chokes, and toe hold are grappling moves. But we also want to be able to label these fighters. If a fighter who wins mostly by strikes, we want to be able to say that they mostly adopt that striking style. And we're going to do this not just for a few fighters, but for around 18,000. And we're going to use around 150,000 fights between them to form this model. So the data set that we used for this project was obtained from SureDog.com via the SureDog Fight Finder. And in this data set, there's around 260,000 bouts between around 150,000 fighters. And for each bout, it's summarized based on who won and how they won. So fighters can win a match with around 50 distinctive styles. And as can be seen, we have on the order of magnitude of the same number of fighters and bouts. So individual fighters generally have only really utilized a small subset of the possible moves they could to win. And in fact, no MMA fighter has won by all 50 of these distinct finishes. Now, because of this, the past performance of an individual fighter is insufficient to predict how they're going to do in the future. And what we need to do to get around this is be able to use information across fighters in order to inform the estimation of individual fighters. Now, I want to illustrate one point, that I'm showing on the right the number of wins that are associated with fighters of different kind of, by experience, basically, pooled within a number of wins. And I'm highlighting fighters who have currently or previously fought in the UFC in red, and other fighters in blue. So the kind of elite, the top tier athletes in the sport really represent a minority of the data that's available in terms of how fights are won. And so we can better inform the understanding of elite athletes by looking at data more broadly, drawing from athletes across the spectrum of skill level. So before I further talk about determining the styles of individual fighters, I want to convey that style is really a meaningful factor in MMA. And so one way style can manifest in this data set is if, in the case of finishes like kicks and knees, we might say those are both part of Muay Thai, kickboxing. So fighters who utilize those styles should tend to utilize both kind of finishes together. So these finishes should be grouped together if we aggregate across all fighters. Now, to illustrate this with a simple example, of how we're going to kind of quantify this, we can consider a fighter with 3 armbar wins, 2 punches, and 1 rear naked choke. Now, we want to basically count the number of times each pair of finishes occurs together. So we see there's 3 counts of armbar to armbar, 6 counts of armbar to punches, 3 counts of armbar to rear naked choke, etc. And so we want to do this for this one fighter. We're summarizing how many times different finishes co-occur within this fighter, and then we're going to aggregate across all fighters. And then we want to determine for every pair of finish, how often did fighters use them together versus what we expect by chance. And we use permutation analysis to say whether these enrichments are significant. So doing this, we find there's 289 pairs of finishes that significantly co-occur in this data set. And we can use these pairwise co-occurrences of individual finishes to lay out the relative positions of finishes in a two-dimensional space. And what's apparent from this is that the finishes form these kind of local neighborhoods, where, for example, if I'm looking on the top right at this little red cluster, those are all submissions that target the legs. And they're all mutually highly connected. So if you're good at winning by a heel hook, you're also good at toe hold, and you're also going to likely win by ankle lock relative to an average fighter. Now, what I really want to convey from this is that finishes are not used randomly by fighters, but rather individual fighters use a subset of the possible moves that are available to them. Now, in order to actually determine the subset of moves that are used by a fighter, we need to be able to say the extent to which each fighter exemplifies a given martial arts style. And this is where the mixed membership model, or 3MA model that we developed, comes into play. So doing this, we want to estimate two aspects of the data set. We want to say, for each fighter, how much do they exemplify a given martial arts prototype? And then we want to say, for each prototype, what finishes are associated with them. And using these two pieces of information, what we can do is predict for any fighter how likely they are to win by a given finish. And we can, if these predictions are good, then we expect that if we use data that's never before been seen by the model, we should be able to predict how likely the fighter is to win by that finish fairly accurately. Now, a couple of operating characteristics we'd like about this model is that if we're assuming there's some differences between fighters, this model should always work better than if we just assume all fighters are the same. So assuming that there's no real style effect. And we also like it as we gain more information about a fighter, so if a fighter has a longer record, we should be able to predict how they win more accurately because we have a better kind of measurement of their individualized style. So this 3MA model, we're able to get at these two quantities using a technique called latent Dirichlet allocation. And what latent Dirichlet allocation is a Bayesian model that basically, where we're estimating two quantities that are akin to these two measures of interest, the fighter-specific prototype mixtures and the prototype-specific finish probabilities. But we're going to put a prior on both of these. And this prior is very important, especially for the fighter-specific prototype mixtures, because this allows us to share information across fighters, where essentially, if we don't have that much information about an individual fighter, the prior will have a very strong influence, and it'll make them tend to look a little more generic. But then as we get more information for an individual fighter, their specific record will tend to dominate the estimate of their style. To see how we can connect these two quantities to determine the probability of a given finish for a fighter, we'll basically sum over the k different stylistic prototypes, and we're weighting each fighter based upon how much they exemplify the prototype K, and how strongly the prototype K is related to the finish J. So we fit this model across a range of parameter values, varying both how many stylistic prototypes exist in the data and very other forms of the kind of priors. And we see that there's around 10 distinct components of 10 distinct styles which people use to win fights. If we looked at a data set composed from how fighters lose rather than how they win, we see that K is only around 3. So fighters kind of lose based on either striking or submission or decision, but there's not a lot of fine-grained structure to how they lose. If we look at this kind of figure in the top right, what I'm showing here is how well our model does when we vary a few different variables. So first off, basically, these bars are all positive, and these are basically showing how much of an improvement there is relative to a model where we assume all fighters are the same. And so we see, in general, if we are looking at losses or we're looking at wins, we do better at predicting wins than losses. Well, it's kind of more under their control, so that makes some sense. If I'm showing here going from kind of light pink to dark blue within a given set, the how our predictions do when we go from fighters who are relatively inexperienced to are highly experienced. And we see there's an increase in all these categories. Now, I'm also showing what happens when we apply our model to 3 different data sets. We could either say, the top tier athletes are fundamentally different from all athletes, and just look at top fighters fighting top fighters, but we see that results in very poor predictions in general. So when we look at all fighters, we're able to predict the very experienced fighters much more accurately when we're incorporating more information from mostly amateur fights. So these 3MA prototypes, I'm projecting them on this kind of previous plotted term from co-occurrence. And what they're doing is kind of capturing this cluster-like aspect of the data, where we see there's characteristic prototypes that make a lot of sense in the context of the sport of MMA. For example, we see 2 prototypes that are associated with striking. One just involves punching, so it's essentially boxing. One involves kicks, elbows, and knees, so it's essentially kickboxing. We see there's 2 prototypes that are related to win by decision, and we see 2 prototypes that are just associated with a single common submission. The rear naked choke and guillotine are each a separate prototype. And these moves are very common in MMA, and so most fighters will know about them and have the capabilities to apply them. We see 3 other prototypes that are associated with submissions that each contain a larger number of submissions. So these are kind of more jiu-jitsu oriented and a little more advanced. So we see one prototype that's essentially attacks the target that are arm bars or leg submissions. We see another that are submissions applied from guards, such as the triangle choke. And we see a third submissions that are submissions, primarily chokes applied from side control and front headlock, which are the kind of commonality between these positions is they're very strong control positions. So the opponent escapes the submission, they're still in a very bad place. The final prototype we see is a class of finishes that were very common around the year 2000 and have since decreased substantially in popularity. So this kind of prototype more than anything dates a fighter to the formative years of MMA. Now, besides just estimating what a set of prototypes in MMA, we have estimates of the style of around 18,000 fighters. And I'm showing the prototype estimates for one such fighter, Ronda Rousey. So Rousey has 12 wins by arm bars, 2 wins by punches, 1 wins by knees. And we see her strong emphasis on arm bars is represented in her prototype makeup, where there's a strong emphasis on P5. But there's also other prototypes in here, such as P8, P9, P3, that are finishes she's never actually won a match with. And this is really one of the strengths of the model, is that we don't have that much information about Rousey. So this is where other information from other fighters is kind of creeping in and allowing for the potential for her win by those finishes in the future, even though we've never seen them to date in her record. Now, with this kind of unprecedented, having this estimate of style for so many fighters, we were able to really answer an unprecedented question, which is, what is the impact of style in MMA? And one way we could think about this at first is just saying, when 2 prototypes match up, who wins? So there's kind of 2 paradigms in which this kind of could exist. There could be good and bad prototypes, where the prototype A beats B and C and D, B beats C and D, C beats D. So there's some rank order of good and bad prototypes, and what the opponent used doesn't really matter. Now there's another model of how this could occur where it's just kind of contextual. And where what an opponent does kind of says how well your prototype's gonna do. And I'd say this is kind of informally favored by MMA fans, where we frequently talk about a good or a bad matchup for a fighter. But we're really able to say which of these models fits the better using an unbiased quantitative approach. Now to look at this, because fighters aren't a pure representation of a given prototype, instead we're going to look at the extent to which each fighter represents a given prototype. And so we take 2 pairs of prototypes, M and N. We can see how common M is in the winners of fights and N in the losers, and then compare that to how frequently how much of the weight of prototype N is in the winners and M is in the losers. So kind of looking at their relative value enrichment in winners versus losers to determine the relative dominance of these 2 prototypes. And we do this for all the pairs of prototypes, and this allows us to basically say which prototypes dominate each other. And we find that the ranked model holds perfectly for this data set, where there's around 5 distinct tiers of prototypes where the upper level tiers dominate all lower level ones. At the top, we see unanimous decision. So fighters who win by unanimous decision, or unanimous decision in general, if fighters emphasize on that, it'll tend to beat all the other 9 prototypes. The second tier is other forms of decision, kickboxing, and these submissions from strong control positions. The third tier includes rear naked choke and punches. The fourth tier is submissions from guard. And the fifth tier is these leg submissions, guillotine chokes, and these kind of year 2000 submissions. Now for this analysis, we were able to show that the kind of quality of a prototype is, they're kind of good or bad prototypes regardless of what an opponent uses. And this suggests that we could look at the style of a fighter without really directly considering their opponent. And the reason why we do this will become clear. But what we're going to try and do is essentially for each fighter, we're going to try and predict how likely they are to win or lose using a logistic generalized additive models. Where essentially we're predicting the odds of winning based on the fighter's individualized prototype mixture and their level of experience. So on the bottom right here, I'm showing the relationship between experience and the log odds of winning. And we see fighters who are more experienced, it monotonically increases the odds of winning, which is expected, but it's a nice sanity check. Now on the top, I'm showing the relationship between the levels of all of the 10 prototypes and the effect on the odds of winning. And we see here there's a very complicated frequency dependent to this relationship. But in general, at high frequencies, the prototype rankings are similar to what we saw in the last analysis. We're kind of on top of the peak. The heap is these submissions from strong control positions, then rear naked choke, then kickboxing, then punches. But what's interesting is if we look at unanimous decision, which is this kind of like goes up and then down reddish color, unanimous decision actually kind of peaks at intermediate frequencies, and then fighters who have overemphasized on winning by decision tend to do worse. This kind of suggests that if you always put it in the judge's hands, that maybe you don't have the stopping power to win by strikes or submissions. Now, doing this approach, we were able for each fighter to estimate how likely they should win based upon their style and experience. And we were able to compare this to the actual true win frequency of these fighters. And we see using experience and prototype mixtures, there's a very strong relationship between the predicted win frequency and their true win frequency. However, we can also remove the effect of experience and look at the role of prototypes alone. We see there's still a strong relationship between the effects of style and the true win frequency. And in fact, the kind of role of stylistic prototypes in general is kind of quantitatively similar to the role of experience. Now, using this kind of estimate of how likely individual fighters are to win based upon their style, we were interested in seeing whether the elite athletes fell in a particular position within this kind of range of styles. And so what I'm showing on the right is basically highlighting all of the UFC champions who successfully defended their title at least once. So the most elite fighters in the sport. And we see they're highly enriched in the right tail of this distribution. So fighters who have done really well in UFC have naturally migrated towards successful martial arts styles. We can look at an even smaller cross-section of these elite athletes. The champions who defended their title the most times, Anderson Silva, Georges St-Pierre, Demetrius Johnson, John Jones, and Jose Aldo. And we see that they're even more kind of narrow in their kind of the prototypes that they utilize. Where these champions, what they have in common is that they all have very strong striking, but also kickboxing generally tends to be emphasized over boxing. We also see that all of the champions have the capability to win by unanimous decision if they have to, but they do so infrequently. So these champions, they have the kind of cardio to fight through a 5-round fight, but they try and finish their opponent by strikes or submissions early, so you don't put it in the judge's hands. Now from this kind of these prototypes, we see that grappling is really underrepresented. And for at least rear naked choke and these kind of submissions from strong control positions, this is a little surprising because we've seen these are very successful in MMA as a whole. But there are top contenders in MMA, such as Jacare Souza and Damian Maia, who really exemplify this kind of stylistic makeup. And it says these fighters are good contenders for a reason. But we see that the guillotine choke and kind of leg submissions tend to be not so much used by champions. And it might be, reasons for this might be for guillotine, if you're trying to apply a guillotine and it fails, you usually end up on your back, which is a bad place to be in MMA. And for leg submissions, if they fail, then usually the opponent can stand up or strike with you. So to summarize, we modeled around 18,000 fighters simultaneously using a Bayesian approach. And this allowed us to weight how much information we had about a fighter with our uncertainty about those estimates in order to, for individual fighters, predict how they're going to win in the future. We found that there are around 10 distinct ways in which fighters win fights that each have an associated set of characteristic finishes. And that if we look at this kind of the levels of these prototypes within fighters, they greatly contribute to success in MMA, where there's a subset of styles that are very effective and have naturally been favored by champions, whereas some other styles maybe should use a little more caution, because when fighters win by those, they tend to win less frequently. And with that, I'd be glad to take any questions. Thank you.
So again, we'll have about 5 minutes for Q&A.
So it seems to me like there's a selection bias with this data in that you can't observe anything about style for a player if they lose. And can you comment on whether you think that's caused any issues or you think it's not a big problem?
So yeah, I mean, we see different things. Like fighters will lose in a characteristic way, they'll win in a characteristic ways. So I don't think they do anything systematically different in the matches that they're losing than the ones they're winning. I mean, there's new data sources that are continually being introduced into MMA that can help shed more light on what fighters are doing throughout the match rather than just at the end. But that's kind of what we're at now.
Hi. So you had that 5-point graph that suggested that there's a ranking among all the clusters. What about within clusters? Was there a good ranking within the clusters, or were they?
Within those, we found there was basically insignificant differences between the relative dominances were so small they weren't statistically significant. So that's how we made those tiers.
Hi, did you separate out data for men and women, and did you see any different results with that? Because obviously with MMA, there's a significant difference.
Yeah, in this set, we combined them together. It would be interesting to compare men and women's styles, whether we could just model them together and then see on the back end whether they systematically use different styles. We haven't done that to date. I think women's data is probably 5 to 10% of this full data set. So I would say this wouldn't adulterate our results for men, but they might be generally misrepresenting what happens in women's MMA.
Was there any impact on reach and weight within the prototypes, which seems to be metrics very much used by commentators and analysts?
Yeah. This is something we've really just looked at style. I think there might be this kind of information might be very valuable to supplement information like this, because a fighter's reach is not very valuable, or isn't that important if they're going to only use triangles. But if a fighter is, a striker, then reach becomes very important.
Woodley or Thompson?
Thompson.
Okay.
Hi. For the prediction aspect of this model, did you run a test set on UFC only? And if so, how did it do?
So this kind of top tier MMA, the MMA top versus MMA top, which I showed briefly, was a subset of fighters that were just fighters who had fought in the kind of top promotions. I'd say UFC, Pride, Bellator, WEC. So I'd say it really, it fits that kind of question. And for that, we saw very similar estimates of the prototypes. but they tended to be more noisy because there's just a lot less data. So that was really, by adding more fighters, we saw that amateur fighters tended to do similar things to elite fighters. So it was just more valuable to add them together.
One more over here.
Hi, did you compare differences between clusters and weight classes, let's say heavyweight versus lightweight, for instance?
Yeah, I mean, I think we haven't done that. I think it would be very interesting because I would say that the submission game is more important in lightweights and striking is probably more important in heavyweights. But yeah, I think we want to make this accessible, so we've just summarized fighters with this relatively naive model that they can be mixed together. But then we want to make it so people can peel out and answer a lot more of these nuanced questions.
Did you do any analysis on the progression of fighter styles through their career?
It's something we haven't looked at in order to, with this kind of, because even very experienced fighters, you're going to have a career of maybe 20 fights. Kind of breaking it up even more fine scale would kind of make it very hard to come up with any kind of estimate at a given point in time. I have a feeling that it's important, but with this kind of approach, we have to kind of assume that fights are exchangeable within a fighter's career.
So let's please give Sean and John a round of applause. Thank you so much.